Dinner's almost done. Then one stuck relief valve traps 15 psi of steam behind a lid the cooker refuses to unlock. This is why Instant Pots get recalled and how to check yours. That part's last. Millions of these cookers sit on kitchen counters right now, sold as the safe upgrade. Safer than the stovetop pressure cooker your grandmother eyed nervously. Here's the trap. When the one part that vents steam fails, that same appliance can spray scalding contents or hold the lid shut over live pressure. The burns are severe enough that regulators force recalls. The whole failure isn't the pressure. It's one valve. Start with how it cooks it all. Here's the simple version. You seal water inside a pot and heat it. The water boils into steam, but the steam can't escape. So it piles up and pushes on everything. That push is pressure. The cooker holds it at a set point, somewhere between 11.6 and 15 psi. That's roughly 1 atmosphere above the air in your room. Say that again. It's stacking a second sky's worth of pressure on top of your dinner. Now the useful part. Out in open air, water boils at 100 degrees Celsius and refuses to get hotter. Extra heat just makes more steam. But squeeze it under pressure, and the boiling point climbs to about 120 to 125 degrees Celsius. Hotter water, same pot, food cooks in a fraction of the time. That's the entire selling point. None of it works unless the pot stays sealed. A rubber gasket rings the lid, and a locking ring clamps the lid to the base. Together they trap the steam so pressure can actually build instead of leaking away. So already you can see the bargain being struck. To cook this fast, the machine must lock a small storm inside a metal can on your counter. That's fine, as long as every part that manages the storm keeps working. That covers how it cooks. Now the part that's supposed to keep you safe. There's a piece inside that senses when the pot is pressurized and physically blocks the lid from twisting open. On most units, it's a small pin or float valve that rises when pressure builds. When it's up, the lid won't rotate. Full stop. This is the whole safety promise in one moving part. Under normal conditions, you cannot force the lid open while there's pressure inside. Even if you yank it hard, the interlock holds the lid captive until the pressure drops. That interlock is exactly why this thing gets called safer than a stovetop model. On a stovetop pressure cooker, nothing stops a distracted cook from cracking the lid too soon. Here the machine simply refuses. Meanwhile, a second part is doing the opposite job. The relief valve, the little vent on top, is supposed to bleed off any steam above the set point. Think of it as the pressure's escape hatch. If the pot pushes past its limit, the valve opens and lets a jet out, holding the inside steady. So the design is genuinely clever. One part won't let you open a pressurized pot. Another part won't let the pot overpressurize in the first place. Two guards, two different jobs, both quietly running while you set the table. Hold on to that word, escape hatch. Because the entire recall story is what happens when the escape hatch jams shut. Here's where it turns. That escape hatch, the relief valve, is a small mechanical part. And small mechanical parts fail. It sticks. It clogs with a fleck of food or thickened sauce. Or in the recalled units, it's simply defective from the factory. Whatever the cause, it stops venting. Now watch the two guards turn on you. The relief valve is jammed, so steam keeps piling up with nowhere to go. And the interlock is doing its job perfectly. It senses live pressure, so it keeps the lid locked. The safety feature that was protecting you is now sealing the danger inside. Pressure high, lid welded shut by design, no vent. The feature became the trap. That's the low point of this whole story, and it's worth sitting in for a second. From here, the recalls describe two ugly ways it ends. In the first, the pressure display or the interlock misreads the pot as safe. A user twists the lid, and it releases while the contents are still fully pressurized. The lid can eject. What's underneath is 120 degrees Celsius or higher, liquid and steam. And it doesn't drip out. It sprays across whoever's standing there. In the second, the failed valve lets pressure build past what the vessel was built to hold, and the weakest seam gives. Again venting scalding food and steam outward. Either path ends the same way. A routine weeknight dinner turns into a burn call, and every version of it traces back to that one part that was supposed to let the pressure out. Now why is 15 psi of steam this dangerous, even after you've switched the heat off? Here's the physics that makes it worse than it looks. Water at a hard boil will scald you, no question. But steam carries far more energy than the same amount of boiling water. turning water into vapor pumps in a huge extra load of heat that the vapor keeps holding. When trapped steam vents suddenly, it dumps all of that energy the instant it touches something cooler, like your skin. It flashes. That's why a face full of released steam causes deeper, faster burns than a splash of hot water ever would. The heat being off doesn't matter. The energy is already stored inside the pressurized steam, waiting. This isn't theoretical. The recall reports follow a grim, repeating pattern. Users describe lids that opened while still under pressure, followed by second-degree burns to the face, the hands, the arms, wherever they happen to be lining over the pots. Once those reports stack up, manufacturers and the Consumer Product Safety Commission, the U.S. agency that polices dangerous consumer goods, step in and pull the model. And these aren't small pulls. A single recalled model line often covers hundreds of thousands of units. In the biggest cases, well over 1 million cookers already sitting in kitchens. One flawed part multiplied across an entire production run. Fair pushback. If it has an interlock, how does anyone get burned? Good question. The answer is that there are two separate ways in, not one. Path 1 is a defective interlock. It unlocks early, telling you the pot is safe when it isn't, and you open a live pressure vessel. Path 2 is the valve failure we just traced. The vent jams, pressure stays trapped, and the pot either gets forced open or fails. Different parts, same result. And here's the uncomfortable design truth. This is a layered system, but the layers aren't truly independent. When a single part fails in the wrong way, it doesn't just remove one guard. It flips the other guard against you. Compare it to the old stovetop cooker for a second. On a stovetop model, you vent it manually. You turn a knob, you watch the steam, you decide when it's safe. A human is in the loop. The electric version automates all of that for convenience. That's the entire appeal. But it also means that when the automatic valve fails, the human check that would have caught it is simply gone. Nobody's watching the steam because the machine promised to. So what should a genuinely safe unit do? Real redundancy. A backup relief valve for when the primary sticks. A pressure sensor that refuses to release the lock until it independently confirms the pressure has actually dropped. And a forced natural release where the machine won't let you rush it. The recalled units failed precisely because that redundancy either wasn't there or wasn't working. One failure and nothing behind it. So here's the whole thing in one line. The recall was never really about the pressure. 15 psi is normal. That's how it cooks. The recall is about one failed valve turning the lid lock, your best safety feature, into a pressure trap. That's the master fault. Now the part you can actually do tonight. First, find your model number. It's on a sticker on the base or in the manual. Search it against the official recall list on the Consumer Product Safety Commission website. That single check takes about 2 minutes and tells you if your exact unit is one of the flagged ones. Then 3 habits that cost you nothing. Never force a lid that won't turn. A stuck lid is the machine telling you there's still pressure inside, so believe it. Always wait for a full pressure release before opening. If the float pin is still up, it isn't ready. And after each use, pull the relief valve and rinse it. Because a clean vent is the one part standing between a normal dinner and a burn. One failed valve behind a lid that won't unlock. That's the entire recall in a sentence. Go flip your cooker over, find that model number, and run it against the list before your next batch of dinner. You know how the pressure escapes now. Next, we open up the smoke detector on your ceiling. The tiny speck of radioactive material that's been quietly guarding your home.